Hi and good day to everyone. Really exciting to talk to you about a hot topic of the day. I'm here for this reason. I want to share with you the interesting topic about how to secure caching. So, what if I told you there is a good way to secure caching in information-centric network using a machine learning? So without further ado, let's start our presentation with a title of Secure Machine Caching, Machine Learning Based Defense Mechanism Against Attacks in Information-Centric Network, presented by Walid Elbreiki on behalf of Jeflila Alimati and Shuhaidi Hassan. So let's start with our presentation outlines. Start with introduction, moving for information-centric networks, see the background of the internet, and then the future internet as information-centric network, see the features and the principle, content caching, and the replication of that with the efficient of content retrieval, the security as well, and the privacy. Move to see the main things and the main point of this research, which is the problem statement. And then the objective, methods, how we have done this research, and then see the finding. Also, sharing the contribution of the society, ending with the conclusion. So the referencing caching. The idea of the internet was developed in 1960s. So the main things of this technology, the idea of that is the resource sharing. So share the resource, among the network. So the fundamental communication model using for this technology was point-to-point. So nowadays, the technology has totally changed. Internet content can be distributed digitally. Behind today's things, the internet users as well are mainly interested in retrieved content with secure. And mean that the content should be secured. So the main things and the idea of today's internet, the host-centric, which means content distributed over IP. If we can see these pictures, all internet users are mainly connected to the host to get their interest. So this host or this server, it will be overloaded and the network will be congestion. So by the overloading conjunction, the internet user will get latency for the content. So now time to shift for multicast to share the content. Started with the web, move to the CDN, and then moving to the peer-to-peer. So the evolution of all things one by one reach to think about the new technology, which is promised to share the content in a secure way, and then caching the content in the secure way, which is as a future internet, the content-centric, the content will be distributed about among or over the ICN. As we can see these pictures, all internet users, they are sharing the content from the nearest node rather than go to the host as the previous pictures. So this is what ICN promised to do in future. So move along to give the definition, real definition, and clearly what's information-centric network. Information-centric network, ICN, is a network architecture that focuses on a content or information itself rather than the location of the content or the identities of the communication path. So the idea behind this technology or behind these things is to describe the user interest in the message header, but not where to get it. So ICN is focused on routers cache content, which is improving the efficiency and reduce the latency. So by routing cache the content, so in cache poisoning, attacking in an ICN Cruz takes the advantage, which is there is an enemy in the network. So they all the attack or the hackers, they will take this advantage of weaknesses in the content retrieval process, which can manipulate the content to a router. So they can play and then change the content and then return back to the router. Move along to intended the feature of ICN. Let's see what's ICN promise. Behind the idea behind this technology is the ICN is promised to increase the bandwidth in the network, also increase the network capacity, and then promise to be neighbor node communication. So also by the communication of neighbor, it gives more secure, less traffic. Also, the communication retrieval by names, not by IP. So these features is ICN promise to be direction of the future internet. Move along to see the principle of this technology. It was the information content unit in ICN. The content unit in ICN is generally called main data object, NDO. So let's define what NDO. NDO, it can be digital content such as video, an image, document, web page. So whatever there content and network, it will be called NDO. So the content in the network is independent of devices that store it. Also, the location independent as well, identifier name. So these things will be, like as a principle of ICN. But today, the design versus the uses, it make mismatch of this data migration, also replication, authentication, and updates are all possible, but unnecessarily hard. We can use this by coding, by torrent. This we can do this, but this one will lead and link for the problems of existing caching, which is the uses of caching data here is helps speed up the application, also improve the user experience and engage people to use their site, as well as storage the data locally. Also, by introduce the use and the benefit of that, caching introduce the risk of cache poisoning attacks. Risk users, it will give the option of risk users confidential or sensitive information being exposed to cyber criminals. So the criminals over there, it will can manipulate the content of the cache. This is first one is the cyber criminals, and then manipulate the content, and also compromise the integrity of the data. This all lead to erode the trust in the content retrieved. All these things, all this problem is introduced and open the area of research. Also, no consistent way to keep ensuring between the content stored in cache and the authoritative source. Move to see the last, not least, of the caching sensitive of private content raises the privacy concern. If caches are not appropriately secured, unauthorized access to cache data may occur. This is lead to data breaches. So with this secure topic and with this secure matter, the security and the privacy, it should be conform. It should be covered. So secure the content data, not the pipe or the parameter. So content to be encrypted by the content provider. You need to secure the content itself, that it's cached in there. The cryptographic encryption is used for private data protection. Each data packet has to carry a signature here. Because why? Because data can come from any router or source in network. Also, signature in each data packet is over the packet name, the content, and on the signed info. Also, we move to decryption. The keys are distributed among content as a data blocks. Also, no need of trusted servers in ICN, because ICN is already promised to be more secure in network. So we move along for the main aim of this research, which is the objective of this research is to investigate and comprehend the various techniques and mechanisms employed in cache poisoning, attacking with information-centric network. So we have done make us a massive and survey, and we make it as comprehensive study totally about the many techniques and mechanisms employed in this research area, and then move to develop the realistic simulation of caching poisoning attack to access their impact on the integrity of caching content in ICN. Third, we measure and then analysis the extent to which cache poisoning attack can lead to the spread of misinformation within the ICN. And then with that, we look at with the evaluating detection mechanism. So we have done 3 research objectives in this research, and then we move to see how we have done our objectives by using the methodology for the machine learning. We'll start with the data collection, move for a pre-process, and then convolutional linear network. By convolutional linear network, go through the gradient Boston trees, and then Boston trees, and then from here we can introduce and then or definition of the gradient post trees, which is GPT, are machine learning techniques for optimizing the predictive value of model via steps in the linear network linear process. And then we need to see the convolutional neural network, which is a type of a neural network used primarily for image recognition and processing due to its ability to recognize patterns in image. So this ability and this features, it can solve and then give the line of ahead of the gradient posting tree, and then moving for the final stage, which is the evaluation of this whole research. And then if we have data set, already data set, we go through that convolutional linear network with the gradient posting tree, then move for evaluation. So by using this methodology, we go through this methodology and then step by step until we come out with our finding and result, starting with data collection, the collected data related to the caching infrastructure within ICN, and then cache devolution attacks, such as the number of requests for non-popular content and the router cache hit rate. These two things, we collected our data, and then we process for the second step, data pre-processing. The collected data is then pre-processed to remove any noise and inconsistency. This involves data clean, data transmission, and data reduction. For the feature extraction, the pre-processed data is then used to extract relevant features that can be used to detect and classify malicious activities. Targeting the caching infrastructure within ICN. This involves using CNN. So this is CNN will give you the classifier of this features, give the feature of the classified, and then so extract the features from the data. So after we give the extraction, we move to a classification stage. The extracting features are done, used to classify the data into different categories, such as normal and malicious activities that involve using GPTs to classify the data. Finally, the final step is to evaluate the performance of the proposed methodology. So this involves using the metrics such as accuracy and the precious recall and F1 score to evaluate the performance of the methodology. We come out with the finding, and then the finding, we find the methodology success rate up to 85% in countering emerging threats, further validating its effectiveness. Second, a score, which is a score of 0.88, indicated that the methodology is very high effective in detection and classify the malicious activities, targeting the cache infrastructure within ICN. Since these two findings we find after we have done our objective, we found it's related by using this methodology. Then finally, we move along for the contribution of this research, which is enhancing the network security and then protection against the emerging threats, then the precious in the tree identification, resiliency, the against the evaluation attack strategy, and then practical the deployment recommendations, and then finally the contribution to the knowledge and the research by this research. So these all contribution start with the enhancing network security. By the enhancing network security, the primary contribution is the domain of the network security. These algorithms significantly contribute to enhance the security of ICN by providing effective framework for detection and classifying the malicious attacks. So by enhancing this network, so we give good performance of the network and good performance in the network. This is what all internet users need and all what he look for a secure and network. And also the protection against the emerging threats. The algorithm successful rate of 85% in correcting emerging threats. Also the precision in the threat identification. The high precision of the algorithm ensures the accuracy identification, the accurate identification of the malicious activity. This precision is essential in minimizing false positive. Resiliency against the event attack strategy, also the algorithm validation of the resilience against evolving the attack strategy with the particular deployment recommendation. The algorithms recommended for deployment a real world ICN environment, significant as particularly to work as a particularly for the real environment of this contribution. And then finally, contribution to the knowledge and the research, the deployment and development and the validation of the algorithm contribute to the broader body of knowledge in the fields of machine learning, cyber security, and network security research. So by these contributions, we give a clearly idea what we have done through our research, and with that we need to with that slide and with that we need to end our presentation, and hopefully everything is clear. And then to say thank you so much for this opportunity to give our idea and to give idea for the abstract, to give more clear about how we can secure caching over ICN using a machine learning. Thank you so much, and we'll see you next time.